Hello everyone, I'm Weichen Zhang from the University of Sydney. Today I would like to share our work Collaborative and Adversarial Network for Unsupervised Domain Adaptation. This work is collaborated with Dongxu and Wanli Ouyang from the University of Sydney and Wen Li from ETH Zurich. In unsupervised domain adaptation, we have a labeled source dataset and an unlabeled target dataset with same classes, given that the source and target distribution are different. The goal of the task is to categorize the unlabeled target dataset into the given classes. Many existing works have been done to solve this problem. For deep learning approaches, if we directly fine-tune the CNN with only the labeled source images, due to the domain data distribution mismatch, the unlabeled target samples may not classify well. So, in domain adversarial neural network, they try to learn the domain invariant features which are not distinguishable from different domains. To achieve this, they use a domain classifier and a gradient reversal layer with using the unlabeled target samples. In this way, the features of different domains become more closer for easier categorization. Therefore, DNN tries to learn the domain invariant features at the final layer, so when doing the backpropagation, all the features are learned in domain invariant way. However, we think that the representation at lower layers are often low-level features, for example, the corners and edges. They are useful for distinguishing not only images from different domains, but also images from different classes. Therefore, instead of learning domain invariant features, we should make these low-level features distinguishable from different domains. In addition, pseudo-labeling method has been proven useful for semi-supervised learning. We also propose a new method that uses reliable pseudo-label target samples that are labeled by the image classifier in order to better adapt to the target domain. For the structure of our CAN model, in formal layers, we use domain collaborative learning, in which use domain classifier D to let the network learn more domain distinguishable features. And in later layers, we use domain adversarial learning to learn domain invariant features using the domain classifier and gradient reversal layers. We also add domain loss function to automatically learn the weighting parameters W's to let the earlier features to be more distinguishable by the domain classifier. Finally, a class label predictor C is used to predict the object category. In addition, for our incremental CAN, in each training epoch, we select some reliable pseudo-labeled target samples in retraining the model. Apart from other methods which only use image classifier confidence to guide the sample selection, we introduce a last domain classifier guided selection weighting method. In details, after one training epoch, we get the prediction confidence from the image classifier C and score from domain classifier DM for each sample. Only the target samples that are larger than the confidence threshold and in between the domain invariance range are selected to retrain the model. In addition, we utilize a weighting function to reweight the contribution of the loss for each selected sample. The weights are greater if the score from the domain classifier are closer to 0.5. In our experiments, we use ResNet 50 as a backbone network and evaluate our model with two datasets, Office 31 and image CRF DA. The result indicates that our method I can achieve the best on all datasets. In conclusion, our method can additionally learn domain informative representation in early layers to learn better low-level features. And I can iteratively perform pseudo-label target sample selection and reweight by image classifier and domain classifiers to learn better features from target domain. Please come to our poster D21 for more details. Thanks.